All right, 8th grade math students, here we go. This is our first flipped classroom lesson. We are going to start out with some review skills, which is nice because we are kind of troubleshooting this whole process together, but I'm excited and I think it's going to be good stuff. So first thing that I want to say is that as we go through these notes, as with any notes that we will be doing in this format, if you have questions, please write them down in your notes and make sure to ask me when you come to class the next day. That is the beauty of this, is that you can pause it, rewind it, replay it. Still, if you are still not sure on what we're doing, make some notes on the side, make your own notes, write some questions down, and make sure to ask me for clarification. This is going to be good stuff, and it's going to let us get a lot more time together working on math in class. So, first thing we've got here is I want you to notice that we are doing some Module 3 review, vocabulary, which is good because we want to make sure that we understand the language that is going to be used in this module. These notes will be posted on Friday, today, October 10th, and will be due at the beginning of class on Monday the 10th. The practice that we're going to do that goes along with this is on page 68, 1 through 18. Do not worry about doing that now because we're going to be doing it in class together. So here we go. Some Module 3 review vocab. What we're going to start out with is ratios. And I'm going to give you the definition and then I'm going to give you a couple of examples. So a ratio is, let's get my pen here, a comparison of two quantities by division. So let's say, for example, we are looking at a classroom of students and we want to make a ratio comparing the number of female students to the number of total students. And let's say, for example, that there is 12 female students and 25 students total. We would write that ratio in one of three ways. We could write it as 12 to 25. We could write it as 12 to 25. Or we could write it in a fraction form or in division form as 12 out of 25 students are female. Pretty straightforward, but ratios are important, especially when we get into proportions. Equivalent ratios, our next definition here, you can think of as equivalent fractions. They are ratios that name the same comparison. So if we look at that example from above of 25 students, and we want to know if we had 50 students, what would that look like? Well, we know that we have 12 out of 25 that are female, and we could say, okay, well, that means that we can say 24 out of 50 would be female, or so on and so forth. You can write them just simply as like 1/2 and 2/4 are equivalent ratios because they will simplify down to the same thing. Another example, 5/10, 10/20, and 50/100 are all equivalent ratios. You can think that equivalent means equal. So all of these essentially are the same value when you simplify them. I'm going to go ahead and move this up just a little bit. Remember, if you need to keep writing, go ahead, just pause it, write it down, and keep going. Unit rates. Unit rates are a rate in which the second quantity in the comparison is 1 unit. a rate in which the second quantity in the comparison is 1 unit. So, for example, a unit rate would be something like the speed limit of 60 miles per 1 hour, because it's a comparison of 1 unit. Something else we can look at is 12 inches in 1 foot. 12 inches will always be equal to 1 foot. So those are two examples of unit rates. There's multiple examples of unit rates, and we will get to some of those a little bit later, but that is the introductory definition there. All right, the next word that we're looking at is constant. A value that does not change. A constant is a value that does not change. So if we look at our unit rate of 12 inches per 1 foot, that is a value that does not change. It is a constant unit rate. And our final word that we're going to look at here is proportion. And a lot of you guys know what proportions are, even if you don't remember what they are. They are an equation that states that two ratios are equivalent. An equation that states that two ratios are equivalent. And already here we've got equivalent and ratios, which, if we just take a look back here, are two words that we addressed in the beginning, ratios and equivalent ratios. So I'll scroll back down. Hopefully that doesn't make you too dizzy. So again, you can think of equivalent ratios or equivalent fractions when we're talking about proportions. So a proportion would be, again, something like 2/3 is equivalent to 4/6. It looks a lot like our equivalent ratios. In fact, it is that. But we're going to be solving proportions. And proportions itself, you look at the word, it is proportional, which means they will be the same when simplified. Okay, let's go ahead and do a couple of review skills. So this is on the back side of that note sheet that I gave you in class on Friday. We are writing fractions as decimals. This is a skill that we have done and reviewed many times, but some of us are still struggling with it, and that's okay. So it's good to have a little bit more practice. If you already know this skill, guys, go ahead. Feel free. Fast forward. If you know that you can crush converting fractions to decimals, only do as much as is going to be helpful to you. But the review is important, so don't be afraid to just take the time and write it down. So if we have, for example, the fraction 17/25, we're going to read that fraction bar as divided by. So read, I'm just going to put a little note here. You don't have to write this down, but I find it helpful. You can read it as divided by, which means 17 divided by 25. The most common error that we have here when we are converting fractions to decimals is reversing the numerator and denominator. You can always think this way as well, is that when you have 17 divided by 25, you can rewrite it this way, or you can think the top number goes inside the division box. So 17, let's go ahead, not 7, 17 divided by 25. Right? Divide the numerator by the denominator. I'm going to go ahead and just put this over here where I have a little more room. So 17 divided by 25. 17, since 17 is smaller than 25, we know that we are going to have to add a decimal, and make sure you carry that decimal up. Proper notation is to put that 0 in front of the decimal, and then I'm going to go ahead and add a 0 here. Now I'm thinking 17 becomes 170, and I want to see how many times 25 goes into 170. Well, that would be 6 times. 6 times 25 is 150, and you guys can be pausing and doing this and then checking your answer as we go through, or you can be doing this with me. I'm going to subtract 150 from 170, and I get 20. I'm going to add my 0 and bring it down. Again, review skills here with long division. And how many times does 25 go into 200? That would be 8 times. 8 times 25 is 200. I'm going to subtract, and I end up with 0. So I'm going to stop there. So 17 25ths is 68 100ths as a decimal. Okay. So we've got 3 practice problems here that we're going to run through. You can go ahead and pause here and try and solve them on your own, and then press play and work through them with me to make sure you got them correct. Or pause, work through them, and then fast forward to see if you got all the answers correct. And then if you didn't, rewind and check your process. So we've got 3/8, and we are going to divide the numerator by the denominator. So I'm going to put my top number in the box here, reading with that fraction bar. I know that 8 does not go into 3. I'm going to add my decimal, add my 0, and then I'm going to think, okay, 8 into 30. How many times does 8 go into 30? 3 times. 3 times 8 is 24. That leaves me with 6. Going to go ahead and bring that 0 down. 8 goes into 8 goes into 67 times, and that gives me 56. Go ahead and subtract, bring down my 0, and now I'm wondering how many times does 8 go into 40. 8 goes into 40 evenly 5 times. Just extend my line out here. So 5 times 8 is 40, and I have a remainder of 0. So that decimal, 3/8 as a decimal, would be 0.375, or 375 thousandths. Okay. These next two are a little bit trickier because they have decimals in them. So we want to make sure that when we are dividing fractions with decimals, that we are going to move the decimal in our front number here. We're going to go ahead and move that over so that we are only working with whole numbers. Whatever I do in front, I have to do behind that division box as well. So I'm going to go ahead and move that one. So now what I'm doing is I am dividing 3 by 4. Now I still know that 4 isn't going to go into 3, so I'm going to still have to add a decimal and my 0. But now I'm working with whole numbers, and that's a little bit less intimidating. So I'm going to add my 0. How many times does 4 go into 30? Well, 4 goes into 37 times. 7 times 4 is 28. That leaves me with a remainder of 2. I'm going to bring that 0 down. 4 goes into 20. How many times? That would be 5. 5 times 4 is 20. And that gives me a remainder of 0. So 3/10 over 4/10 as a fraction would be 75 100ths as a decimal. I'm just going to take a little aside here. There is something you can do with these two. Another way that you can solve these, and I want you to use the way that works best for you, and that would be to look at this and multiply both of these by 10. What that essentially is doing is just moving that decimal over. So again, you have 3/4, and a lot of us know when we look at 3/4, we already know that that is 75 hundredths. So you may not even have to do all of this, but it's good practice. All right, and our final one here, 13 hundredths divided by 2/10. So let's go ahead and set this up. 13 hundredths. I'm going to go ahead. I forgot my 0. And backtrack that just a little bit. 1300ths divided by 2/10. Now I know from my last problem that I need to move this decimal over 1 so that my front number, my divisor here, is just a whole number. And then whatever I do in front, I have to do inside as well. So I'm going to move that decimal over 1. So now I've got 1 3/10, or 1.3, divided by 2. So this inside number is still a fraction. That's okay. This outside number is now a whole number. That's what we want. So 2, make sure you carry that decimal up and add that 0. Now 2 goes into 13. How many times? 6 times. 6 times 2 is 12. And I'm just ignoring that decimal while I go through this process. 13 minus 12 is 1. I'm trying to go until I have no remainders left, so I add that 0 and bring it down. 2 goes into 10. How many times? That would be 5 times. 5 times 2 is 10. And I have 0 remainder now. So that means that my decimal, 13/100ths over 2/10, or 13/100ths divided by 2/10, is 65/100ths as a decimal. Okay, so that is writing fractions as decimals. This is, again, a review skill, so if you sped through this, just make sure you check your answers on those practice problems and so that you know that you are doing them correctly. Our final review here skill, let's try that again. Our final review skill is solving proportions. So, we know that what proportions are based on our vocabulary, and that is an equation that states that two ratios are equivalent, or equivalent ratios, or you can think of them as equivalent fractions. And there's two methods for solving proportions. The first method is, well, let's take a look here. We got 5/7, and we're trying to find out what x is. We're solving for x. So what that would equal as 14ths. So the first method here is to look at this proportion and say, okay, well, 7 times 2 equals 14. Whatever I do to the bottom, I have to do to the top. Whatever I do to my denominator, I have to do with my numerator. So I'm going to multiply that by 2. So I know 7 times 2 equals 14. So I'm going to multiply 5 times 2, and I'm going to get 10. So that means that x equals 10. And I can check that just by going back here and plugging it in and saying, okay, well, 5/7 should be equal to 10/14. 7 times 2 is 14. 5 times 2 is 10. Looks good, huh? So that was pretty simple. There's a second method, and this one is maybe better used when you have larger proportions or things that are a little bit more complicated. It is entirely up to you which method you want to use, and maybe you want to use different methods at different times. So let's take this example. 2 over x equals 16 over 48. And we're trying to find out what x equals. Again, you could use method 1 and say, okay, 2 times 8 is 16, so what times 8 is 48? The opposite of division would be multiplication. So you would need, of multiplication would be division, so you would have to divide to solve, which is essentially what we're going to do with our second method here. So we are going to cross multiply, and we're going to take 2 times 48. Oops, I'm writing the wrong numbers down here. 2 times 48. And we're going to set that equal to the other 2, which is x times 16. Now remember that you can always write multiplication as 16x. That means 16 times x. You can use the dot or you can use the little x, but when we're using x as a variable, that can be confusing. So 2 times 48, that is 96. And now I have 96 equals 16x. So I know this is multiplication. To solve, I have to reverse this. So I'm going to divide by 16. And that's going to let my x be by itself because 16x divided by 16 is 1x. And then 96 divided by 16 is 6. I just did that math quickly. You can use a calculator to solve that, or you can do it in long division. That would be fine too, but just for the sake of time here. So now I know that x, whoops, writing this backwards. 96 divided by 16 is 6, so 6 equals x. And I'm just going to plug that in to check and make sure that makes sense. And I might check with method 2. So this should say that 16 times x should equal, excuse me, should equal 2 times 48. 2 times 48 is 96. And 16 times 6, which is x, also equals 96. So I've got 96 equals 96, x equals 6 is correct. Now you could have used method 1 here. And again, if you guys are feeling good about this, let's go ahead and fast forward through this part and skip down to the examples, the 3 examples, practice problems down there, and solve those. If I use my first method, I know that 2 times 8 equals 16, and so x times 8 should equal 48. So I'm going to reverse this, and I'm going to say 48 divided by 8 to find x. Well, 6 times 8 is 48. I'm just double checking that. So I know that x equals 6. That method is a little bit faster, and it works with some simpler proportions. It's important to know the second method because that does come in handy down the line. All right, what we're going to do now, we've got 3 practice problems here that we're going to go through. If you want to pause the video and solve them and then fast forward and check and see if you got the answers right, that would be fine. You can go ahead and do that. I'm going to go ahead and move this. That's good. And then if you did not get them correct, go ahead, rewind, and see how we are doing these. Move through them together. Okay, so we've got 20/18 over 10x. So 20/18 is equal to 10 over what? So we know that 20 divided by 2 will give me 10, right? So 18 divided by 2 would give me x. 18 divided by 2 equals 9. So that means that x should equal 9. I can plug that back in and check and make sure that that is correct. But x equals 9. Pretty easy peasy, right? Okay, so 20/18 equals 10 over 9. The second one we have here, we have x over 12 equals 30 over 72. Now, I know that I can multiply something, 12 by something, to get me 72, but maybe I don't know exactly what that is. So I might need to do a little division here and say, okay, well, I don't know what I have to multiply 12 by, but I can certainly divide 72 by 12 and find out. And that's going to maybe just be troubleshooting for you. You know, 12 times 2 is 24, and you have to go through that, and that's fine. But 12 times 6 is 72, and we can just double check that. So now that I know what I have to multiply 12 by, that's going to tell me that I have to multiply my top number by 6. So I don't know what my top number is that I'm multiplying. So I'm going to reverse that operation. I'm going to say 30 divided by 6, and that should give me x, should equal x. And 30 divided by 6 is 5. 5 times 6 is 30. So what does x equal? X equals 5. So that proportion written out would look like 5 over 12 equals 30 over 72. So you can use this method to solve, or you can use that cross multiplication method as well that we did up here. That would be okay as well. And this last one that we're looking at here is x over 4 equals 4 over 16. This one's a little bit simpler. So 4 times what gives me 16? 4 multiplied by 4. So 4 times 4 is 16. Something times 4 gives me 4. What times 4 gives me 4? Well, 4 divided by 4 is 1, right? So 1 times 4 equals 4, which means x equals 1. So if we set up that proportion solved, 1/4 should equal 4/16. So that means that x is. The end product of all of these, the end result, when you are solving proportions, should be equivalent ratios. Should always be equivalent ratios. If they're not equivalent ratios, if they're not equal fractions, go back and check. The end result should always be equivalent ratios, or you can also think of them as equivalent fractions. That should be what you're solving for. And that, ladies and gentlemen, is it for our first flipped classroom lesson. It was strange not talking to you guys and not getting feedback from you, so please let me know how it goes. I know I'm stumbling over my words a little bit here still, but we will all get better at this. And so tomorrow, or Monday when you come in, we're going to be working on these review skills, and then we will get started on Module 3.